Okay. That's pretty focused. Alright, so let's check chat is working. Yep. Um yeah. Yep, sorry for being late, and for not really being set up either. I'm just gonna go through and get everything organized in that regard so that we can get started today. Um, so yeah, straight in the distributed systems folder. Opening up. Well, we'll see what needs to be opened up later. No need to start Visual Studio Code just yet. Um, Alright, so just a few words. Well, as far as streaming is going, I found, I don't know, the past couple of days I've just been really tired in the morning. I slept sort of 9 hours, followed by 8 hours, and still feel really exhausted in the morning. So, session that was meant to start at I think 11 a.m. It's now 1:30. Part of that is that I went out and did a couple of raids in Pokemon Go, right? And so it says, well, I started at 135, whereas I was intending to do 125. And I mean, I'm pretty experienced with Pokemon Go. I know how long everything takes. Ah, shit! I forgot to reduce to remove the couple of Pokemon Go text from the description of the title of the stream. Um, yeah, I guess I could do that now if I can remember how to edit titles. Um, I have to thank the couple of you who followed me a couple of days ago. That's nice. Stick around and see what you find. I don't particularly aim to provide. I aim to do my best, but I don't. I don't. I'm not under any illusion that what I'm doing is worth watching. So as much as you wish to stick around, that's awesome. Yeah, is there a way? Is there a way of editing the stream title straight from Streamlabs? I mean, I know there is, but I can't remember what it is. And honestly, I don't care sufficiently, so I'll just leave it. We're all right. Um, yep. So yeah, I mean, people are just so casual about Pokemon Go. They'll just arrive 10 minutes late, and 10 minutes is precisely how much later I started after I said I would. So that delay basically carried straight over from the meeting. And I was already late because I went to bed a bit late. So the next session is going to be Monday. I've already decided it's going to be Monday, so tomorrow in the evening. So I'm just actually recovering. Hopefully get into better sleeping habits because I'm finding it difficult to get into my project at all just because I'm kind of going from day to day, not quite making my stream sorts of targets in terms of when I want to be doing stuff. Uh, not a massive issue. I'm kind of okay with it now, but 9 p.m. I should be feeling a bit more like good, good about things, good about myself, and more hyped to be streaming and to be, well, a bit more productive with the work as well. So yeah, that's that. No worries. I'm here now. I'm gonna stick around for a couple of hours as usual. I think. After that, I bought a iPhone repair kit. What a fucking fly landed on me. Bought an iPhone repair kit from Amazon. It was cheap and it's shit, and it has the kinds of tools that break on one use. So I'm gonna try to best case I can actually get my iPhone working again. The one that I broke in March because I landed on it in the snow. I just slipped and crunched it across a battery pack that was right next to it in my tracksuit pocket in the snow. Best case, I fixed that. It works again with a shit cheap screen. Acceptable case, I do a data recovery and pull back some photos and notes that I left on it, and worst case, nothing happens. Any of those cases is fine, really. I'm just going to give it a shot and then buy a new phone accordingly, hopefully. Is that fly number 2? It's probably the same fly. So many insects in the summertime. Okay. With that, I think we're ready to start. The project so far, so I've been a bit tired and busy actually. I went to another SoFar yesterday, that was a bit strange. It's like a secret lineup, secret location gig. It's not particularly interesting musically. I mean, that kind of thing. You don't do it for the music that much, to be honest. It's just a friend thought it was a good idea. So it was fun. But yeah, I mean, I haven't had time to VOD-ize my previous stream video, my previous past broadcast. But basically, actually, the previous stream was actually pretty good, in my opinion. 6 minutes already, dear lord. Time is just flying. Oh, I'm not at MIT. I'm doing their coursework just from the website, so I'm not even a comp ski. I'm just learning, I'm just picking up the coursework and teaching myself by doing, just by going through their projects. So I'm not at MIT. Otherwise, I might not get away with like putting all my work up on GitHub and that kind of stuff. Yeah. So yeah, I was happy with the previous stream. We made some progress. I finished my recap, so I'm done recapping because it took a 6-week break. I've just been talking about not work for 6 minutes, I realize. So I've been happy with it because we went over some like subtleties, like some design decisions that I thought were quite subtle, and I managed to kind of get my head around exactly why I did things the way I did them. There's my recap, particularly the recap over the codes, is there's a link to the GitHub bottom right of my stream page in resources, and you can in Scrap you can find the sort of code so far that has a kind of blueprint of technically exactly how I've coded it. With that, I'm not going to go through it now, but this isn't motivated. So what I was doing last stream was I was sort of explaining exactly why I thought it made sense to have things tick exactly these ways. So technicalities along the lines of, okay, I send an election reset trigger. If I am receiving an RPC and the sender dominates the receiver, what that means is that the sender's term, what it thinks the election term is greater than or equal to what the receiver thinks. And so, in abstract, it's kind of, why would you do it that way? But that's the kind of stuff that I was talking about in the previous session. And the design decisions I made along those lines. And so this session, I'm going to do part B, as in I'm going to start. I kind of started reading it last time. So I'm going to try to just sketch it out in Notepad, just the way I've been sketching all this out. So I think I have a document ready. This is just something that I found in a paper while I was reading yesterday. We'll probably be going over that today. But yeah, basically I'll be sketching it all out here pretty imminently. Yeah, it is. I'm kind of constrained, right? I'm constrained in the sense that I don't really draw much. I've been doing everything in Notepad basically. I think if I were not streaming, I would probably be doing it a bit more on paper, but I couldn't be bothered to do like focusing the camera with showing my like drawings and whatever. So there's definitely been these kinds of diagrams and fucking nonsense. I think it's extremely Well, I'm not a Komsky, so I don't know, but I think it is very complicated, if not hard as such. I think if you break it down, it's okay, but it's just so complicated. There's just so much stuff. Uh, so yeah, it's cool to hear that you've been through that process. Diagram it to prove it to yourself. Um, yeah, having done part A, I've done leader election and heartbeats. Right, that's what's part A. I'm curious, by the way, if you're at MIT. Um, just off the cuff, curious. Um, but yeah, what was I saying? Part A, I've done. I actually did it weeks ago, so I had to recap it a few days ago. Leadership election and heartbeats. Leader election and heartbeats. And so what I'm doing next as part B is going to be the full data cycle. So the whole, how does data get from the client through Raft to the server with the writing to the log and the committing to the log, that whole process. I called it a kind of 6-step process. So I may as well just describe what I mean by that. It's kind of along the lines of one, client sends data to Raft leader. 2, leader sends it to followers. 3, followers um, acknowledge receipt, and leader commits when majority acknowledge, and yep, followers commit based on leader. And that's 5A, and 5B is like leader sends to service, and it's like clients Raft service. This is the kind of basic idea of how data works, I think. I'm not entirely sure this is completely correct, but I think this is how it works. Just a sec. No, but I use etcd professionally, so I wanted to know how it works. This is, I'm guessing that's one of the uses of Raft, which I have done none of. So I'm still taking it on faith that Raft makes sense and is useful. MIT's project, there is I mean, I'm doing project 2 out of 4. So project 3 is about a key value service that is based on Raft. So that is what is going to be here in project 3, but project 2 we're only working on Raft, and so we just need to establish the connections between clients and Raft and service, whatever the service happens to be, and this stuff, which is the internals of Raft. So, these are kind of interfaces with the outside world, and these are the internals. I'll tell you what, I'll Google etcd. I'm kind of curious what that is, very briefly. Yeah, distributed key value store. I mean, that is what part 3 is in this project. I don't know if it is this one or if it's just one that MIT made up, but I'm going to be doing the same thing pretty much as project 3. I've not yet decided if I'm going to stream project 3. The advantage is I keep all the benefits of streaming, the kind of being able to say exactly what I'm thinking. The advantage of not streaming is I get to just like go to the park on a summer day and just do the project in the shade. Yeah, pretty much. Kubernetes. Yep, I've heard of that. For config data. Okay. Okay. Kubernetes. I don't remember what that is. I guess yeah. You're saying the dominant platform for cloud deployments of like um, some sort of virtualization in the clouds. Yeah, I mean, for me personally, I don't distinguish too much between what all the web service, all of the that is a massive wasp. What all of these services along the lines of Kubernetes, and I have heard a few others, they don't come to mind. What they do, how they're different from each other, all that stuff. Just because I've never used them before, right? I've never had a motivated case for using them. Um, but I mean, yeah, I take the idea. Just somewhere to deploy a distributed configuration system, and that's your key value store, etcd. Okay, that's cool. That's fun to know about. It gives this slightly more motivation because at the moment it's all very much just Raft is a kind of nice thing, and I just want to know how it works. I have no idea why it's being used. Just have vague ideas. But that's why we have Project 3. Actually, I'll just show you Project 3 quickly. Um, yeah, not this is not. It's not etcd. It's probably just like a toy model. But we'll get to that when we get to it. Okay, let me. Mum's come back, but she'll just pass through. Uh, Let me get started. I don't want to gas all day. Um, it's actually getting quite cold, so I'm going to turn the fan off. I have a fan, an external fan for my laptop because I'm using a small XPS 13. It just overheats like if I don't fan it. Um, okay. Sorry, my mum's being a bit. I mean, we have a dodgy lock, and I think she might not be able to get in. So I'm gonna go and open that. I'll be right back. Uh, Fucking hell. Okay, one moment. Yeah, it is unlocked. It just jams. Okay. Sorry about that. That took a bit longer than I thought it would. Let me just sort myself out. Whoa. I might not actually be able to. Is that where I was? Where was my camera? I'm gonna have to refocus that. Okay. Yeah, that's not too bad. Okay. Yeah, I might not actually be able to stay too long, just because my mum's come back and she's not in a good mood. But for the time being, things are okay, so I'll just push ahead. Just had to sort of jump out to help her move food, pretty much, because she went shopping and there was just a bunch of food, and should be peaceful now, though. All right, well, I mean, after all that talking, I guess this is a good kind of okay. I'm done. I'm done with all that gassing about how I'm going to sort of get started and get myself organized, and now we'll have a look at the sort of data phase. I always call it a phase. It's not really a phase. It's a cycle, though. Yeah, it's a cycle. It's like the mineral cycle or anything like that. What happens to the data when Raft is dealing with the data? Something along these lines. Um, I'm happy. Am I happy with this breakdown? So I typed it out quite quickly. I guess this is the idea that is in my head at the moment. Um, RPC send, RPC receipt. This is it's all via the append entries RPC data. Um, that's just according to the Raft specification, how we're going to be implementing that. Leader sends it to followers, and then the followers acknowledge by replying with success, literally. Leader commits when majority acknowledge, so that's part of the heartbeat cycle, I guess. Um, Followers commit based on leader. Um, Having committed, and leader sends to service independently. Yeah, it's slightly unknown how exactly all of this works to me. I did try to sort of. Sorry, a bit of chav music being distracting at the moment. Um, I did. What was I saying? Sorry. Yeah, I did try to sort of go through all of this when I was first trying to summarize Raft, and that's in like session 3 or 4 or this kind of stuff really early on. It was just because it is like such a complicated thing. I did end up spending a lot of time on my first attempt to summarize it, and um, now I've kind of decided I'm going to just do the data part from scratch, with a bit more experience, I guess, a bit more understanding of what's what. Uh, Sorry, voice crack. But yeah, I'm happy to just start with the summarizing, start with the the entire process, which is going to be fun. Yeah, a bit of extra information here that I summarized last stream. I'm going to go over that when the time comes. But for the time being, let's summarize. Or sketch. This is the sketching phase, pretty much. We're already about 26 minutes in, aren't we? I haven't managed to get much work done so far. Just trying to get everything together. But now's a good time to actually, I guess, start sketching. So I'll just put in a chat note, which is the usual way that I sort of mark, okay, I'm beginning to do something now. Which it also helps me when I'm splitting things up into VODs, highlights, section by section afterwards for the Twitch collection. Okay, so check it out. This file, blueprints, bottom right of my Twitch page, it's the blueprint in the resources list. This is what basically contains all of the useful information about Raft. Well, not all of it, actually. I've mentioned a number of times that I've spotted things that have been like missing. Or just like really badly written out and organized. And this is, it's not written as neatly as I would like it to be, but still, it basically summarizes the entirety of Raft. We have basically the whole thing just written down. And we just have to, convert that into code, because this is in no way written as an actual program. It's just a bunch of stuff, and the way they've organized it is not great either, to be honest. State variables, RPC stuff for both the RPCs that come under Raft, the structs and receiver notes. Sender notes are mostly contained here because reasons, rules for servers, just like, make sure it does all this. Basically. So let's just go off of that and try to go through it step by step, sketch it out, and have an idea of how we're gonna implement it all. So how, not just what we're gonna try to do, but also have a kind of preconception of how well we think it's gonna work with all the code that's been done so far. So if it's going to fit with leader elections, if there aren't going to be too many problems. MIT's, of course, it's provided lots of notes, helper notes, like in the comments of the code and also in the actual Raft lab, which there's a link to this on my Twitch page, the entire course of work page, or you can just Google this. That's good enough. And I'm doing part B, right? So if you scroll to part B, it's just like these kinds of hints. This is C. These hints, which I sort of went over them, last time I was streaming, was 2 days ago, I think, and I'm mostly happy that I've actually avoided most of these kind of pitfalls. Unneeded elections, perhaps not. I did mention that there is one sort of situation in which I do unnecessary elections. That's because I don't have. I forcibly interrupt codes basically if there is a. The whole system is structured as a kind of elections are reset. That signal is sent whenever a receiver receives a valid either request for election or append entries RPC, request vote or append entries. Sorry. So if something receives an RPC and the thing that sent the RPC is more up to date on term, then it immediately cuts off, and that is a situation in which an election that's going on could get interrupted, even by a request for a vote. Not just as is in the specification when append entries is supposed to interrupt it, like a heartbeat is saying, okay, cancel all elections because we have a new leader. But I'm also saying if we have lots of candidates, there is a chance that um, basically what could happen is that two candidates, right, that jump up at about the same time, so there's a kind of split election situation. In my code, they have the same term because they've both incremented from like the previous situation. They have the same term, and what that means is because they send each other request vote, they receive a request vote from something that has term that is greater than or equal to them, and that means that they become follower. So they both cancel their elections, even if one of them might have won said election. Right, and that is what's supposed to happen with heartbeats being received, but not necessarily votes. But I'm not going to change that because it's simple and understandable and predictable. I'll change it if it goes wrong, but that's just an example of how my code may have an unnecessary election, and that's something I picked up on last time. Um, Pretty much everything else, sending out heartbeats immediately, I do that. I very strictly, I made it synchronous so that the heartbeats immediately go off. And things like bugs in election timer management. Well, it's not bugs; it's a feature, but it might not be such a good feature if you see what I mean. Um, this is. I feel like I have a good enough handle on Go for this to be completely fine for me. Code that waits for certain events. I don't actually use sync at all. Somewhere it talks about sync condition variables. You know, that's part of the sync package. Sync condition variables. No dropped frames. So got a bit scared for a sec for some reason. So I don't use that. I use Go's concurrency with message passing pretty much exclusively. I don't use synchronization type concurrency. Another thing I spoke about last time. And this is, you know, because I've recapped it and gone over it again, I'm pretty hot on this as well. So the election restriction is the thing that I actually had to pull out of this random, because I didn't read the paper, because I'm doing it all off improvised coursework. The election restriction, I had to go through the paper and read this in order to follow the hint. And so I copied out the stuff that I didn't know, which is how to define logs being up to date when checking for whether or not you should grant somebody a vote. You only want to give votes to servers that have up to date logs. That's one of the things. And this is a precise definition of the log order relation, basically, which is something I had a misconception about beforehand. The reason for that is because none of this is written down in the diagram. So it's just not present here, the definition of the order relation. Everything else, I think, is in the diagram. So I just read the diagram and I should be okay to implement Raft off it, just after a lot of effort, obviously, of reprocessing information. But I mean, I think as is, it's all pretty solid. Uh, Yep, okay, I just checked periodically that my camera didn't freeze because it's possible for that to happen with my new streaming setup. But I mean, it's all good. So that's it. Oh, fuck's sake, no. Do not alt tab, you might minimize the camera by accident. Dear lord. Um, so okay, yeah, that's it. So, can't remember why I started talking about all that, but I guess I'm just, yeah, I was talking about how I processed the blueprint. And hints and things and what I've done so far. A quick re-summary, I guess. But I'm gonna get on with actually doing trying to get my head around the data phase. So, okay, I'm gonna send another random exclamation mark into chat just as another kind of mental note because I managed to spend another 8 minutes without properly starting. This is how it all ends up taking so long because I keep kind of re-summarizing myself on stream. So that's okay. Well, it all begins with this, the data cycle. So of course, I have an idea of how I think it works. This is it. I've highlighted it. And that didn't come from the diagram. the sketch blueprint. Rather, it came from the illustration. So bottom right, again, of my Twitch page, resources, Raft illustration. There's an online demo, and that made it fairly clear, I think, how this works. And so I pulled this off just by following it step by step through the demo. That it kind of works like this. Although it's subject to change, I'm not entirely sure it's completely correct, but we'll see how it goes. But the point is, this gives me an outline for a step-by-step implementation. It gives me a strategy for how to sketch and then do part B. So I'm going to try to follow it. So what I'm going to do is have numbered sections, like 1, 2, 3, like that, and each one's going to correspond to one of these. And there I'm going to write about implementation details, basically. That's what I'm doing. Also tune mainstream hip hop happening in the background. Kind of a depressing sound. But alright, let's go. Let's do it. Oh, fucking so much stuff. What do I look at first? Do I look at step 1? Or do I look at the state variables? I guess it doesn't matter. Okay. Because I have a preconception of how I think it's supposed to work, what I'm going to do is look at the state variables. So the first time I actually tried to summarize Raft and learn it, I looked at the state variables first, and that wasn't that helpful because I didn't have a clue why we had, for example, next index, vs match index, what the difference was between these two, commit index and last applied. But now I feel like is a good time to, because I have some idea, I have some motivation there. I feel like now is a good time to actually try that out. So I'm gonna take a crack at let's just do that. Let's do the state variables first. I'm gonna blow my nose first because the weather's just changed so much. In 2 days, it's gone down by about 12 degrees, and it's just a massive wind outside as well. Thank God, like I was overheating so hard before. It's actually quite cold now. Okay, so I'll just blow my nose quickly. Control 0 to mute, Control 9 to unmute. I set those up myself on Streamlabs. Streamlabs OBS. Open Broadcasting Service System, I don't know. Still paranoid about the camera, sorry about that, but it's working. Okay. State variables, that's what we're going to start with. Not just state variables, but also the RPC variables, so the information that's sent via RPC. RPC, by the way, remote procedure call. It's the protocol used for the servers to communicate between each other because it's completely decentralized. All the servers run exactly the same code, and they communicate via RPC, which is a handshake. Server A sends to server B sends a reply to server A. And so there are sender arguments, there are receiver arguments, as in stuff that is sent from one to the other. Sender data, receiver data, sender function, receiver function. It's all, in the code it's fairly simple how all that ticks over. So learning all the variables that need to be in all those messages and also just the state variables that every server maintains for itself. And the server only knows about its own state, as well as obviously the stuff that comes through RPCs, send and receive. Okay, let's try to summarize what's what. So things like current term voted for, I know what those are. Those have already been implemented and it's completely clear how they work. Same goes for like term, every term. You know, term is, I know what terms are. Those are part of the election cycle. And candidate ID is just who is the sender, leader ID, that kind of stuff. Oh yeah, followers actually redirect clients. That's quite interesting. It didn't even occur to me that I'd have to implement that actually, because I did say client sends to leader. The client sends data to Raft leader, but actually the client just sends to one of the servers, and so they might need to redirect to the leader, or at least it replies like, okay, your send failed because you sent to the wrong server. Try this server, or something along those lines. It's something to think about later. Um, okay, log is fairly. I feel like log is fairly clear what log is. It's just dlog. Sorry about the Internet Explorer's bouncing me about. Log entries. Each entry contains command for state machine, which is the pure data, and the term when the entry was received by the leader. First index is 1. Okay. Sorry, my eyes are a bit dodgy today. Just ongoing colds from the weather changing and whatever. Okay, let's go state variables. Log. Okay, log. It's an array of some description. It's 1 indexed. First index is 1. Log entries. Entry format is command, which is the actual raw data, and term received by leader. Term when received by leader. And to get it all to just fit on one line, I'll write it like that. So the command itself and the term when it was received by leader. Okay, well, it will be clear. I mean, you can even just read through this stuff. Last entries have terms that are compared to figure out who should be more up to date on the log when it comes to resynchronizing servers if they get out of sync on the log. So that's the kind of situation in which case that's going to become important. Log length is also important. So, last term is precisely this, the last one of those, and the length is just the length of the log. So that's okay, that's fine. Let's keep going. This shit is the hard shit, to be honest. Commit index. Give you. Last. That was a random sound. Sounded like a Zelda NPC there. Whoops. Dear lords. Okay. Commit index, yeah? Index of highest log entry known to be committed. This is all servers. So the leader is legit in the sense that the leader, what the leader thinks is the last log entry to be committed, I think the leader is the authority on what is the last log entry to be committed. Situations, of course, though, you have when you could have multiple leaders because, like, there was a network partition and one of the leaders got disconnected without realizing. These kinds of situations mean that I guess the leader might not know. But it doesn't matter. For the time being, all we care about is that everyone is trying to figure out what the highest log entry known to be committed is. So the index of that. Initialized to 0, because of course 0 doesn't represent a log entry because it's one index. So 0 just means nothing has been committed. That's quite clear. Increases monotonically. That's an assertion. fine. It should. Well, if it doesn't get, this is the thing. Commit is all about what we know, as opposed to just writing. As in, if you write to a log, that can get edited if something went wrong, but commit really should not be getting edited, I think. Commit is about, we're pretty sure that everything is sorted for the data so far and we can move on. That everyone agrees. There's been consensus, basically. So that's why increasing monotonically is a reasonable assertion. Okay, index of highest log entry known to be committed. So what I think is the highest log entry known to be committed. Highest committed entry. I think commit is not dependent on server. I think it's universal what is committed and what isn't. Again, not certain. These are the kinds of things I don't quite understand because I didn't read the paper properly, but it'll become clear as we continue. And this is the same idea. Index of highest log entry applied to state machine. So notice it doesn't say known to be. It just says applied to state machine. So okay. Highest entry applied to service. So applied, it's all a question of nomenclature. What does commit mean? What does applied mean? And the usual just write to a log as well. So leader writes and sends to followers. Followers writes and acknowledge receipt. Leader commits when majority acknowledge. This kind of stuff. So the words here are really important. Write and commit. And when it says apply, sends to service, applies. Okay, it does send it, yes, but the point is that's a send to the service. But the point is these are the basic. The three definitions, the three words that we are using in very specific ways, and will continue to consistently use in those ways, to denote these three phases, basically. So this is just, okay, the leader has some data, it writes it down. The leader commits when the majority has that data. So commit is all about the majority being agreed on the data. And applied is the actual, if it's been committed, I'm ready to send it to the service. So those three things. So notice, commit here, applied here, and so those correspond to those things. And this, it doesn't say what I think is. It's just I think this is either they didn't write it down, or it's actually a subtle distinction that everyone knows what the last applied thing was. Well, we'll see how it goes in practice later. We will only really know what these things do, how they work, once we've implemented them and have some sort of system running. Okay, this is... stuff that the leader... Reinitialized after election, leaders have some state variables, okay? So... leader variables reset when leader variables resets on becoming leader, basically. As soon as something becomes a leader, well, it says here reinitialized after election. What it means, there is successful election, like the leader getting elected. So as soon as it becomes a leader, it should reset the leader variables. Two leader variables are next index, match index. Okay, two things. What I do know about these is that they are arrays corresponding to each entry, the indices correspond to the peers. So this is the leader keeping tabs on all the followers, right? So the leader knows about the followers and it keeps the information here. So we just need to find out what next and match are. I'm going to call them peer indexed to make it clear that that's what that means. What I mean by that, as in, yep, each entry of next index corresponds to the next index of at peer I, right? That's the ith index. Same goes for match index. For each server, that's what that means. Index of the next log entry to send to that server. Index of highest log entry known to be replicated on the server. Okay. Index of the next log entry to send to that server. Next entry to send to server. Yeah, peer. I'm happy with peer. Index of the next log entry to send to that server. Init leader last log index +1. So it's initially the leader last entry +1. What that really should say is my last entry +1. Oh, that does fit on one line. Does it? I won't when I close the bracket, damn it. Fuck's sake. Yeah, I'm just gonna use camel case instead, that should make it nicer. Okay, and match index, what did we say that was? Index of highest log entry known to be replicated on the server. What I think is index of highest log entry known to be replicated on server. I'm gonna put replicated because that could be it could be a subtlety that there has to be some sort of agreement or something for match index. And this one also increases monotonically. Do I have my up arrow? How do I copy that from here? Okay, camera is Gucci. So I'll just put these in as notes here. What I think is peer's last replicated entry. That's what it says, right? Index of highest log entry known to be replicated on peer. Perhaps it should say highest rather than last. Replic. Yeah, replica. That's fine. I wish ANSI would die, whatever the fuck that means. ANSI and ASCII, I could never tell you the difference between those. Some just out of date text conventions. Formatting, what is it? encodings. Okay, so let's just keep that there. Okay, let's not spend too much time on that. And we also have, we also have information about, well, a few RPC entries and things. Some information here and here. A few more state variables to look at. What information needs to be sent. I think personally, I'm not gonna summarize those yet. So the RPC variables, I don't think we need to look at those yet because it should become clear as we are going through the RPC implementation why we need them. And it should be like, okay, yeah, we need to send this information, hence. I think that's a faster, more efficient way of going through those. Whereas I do want to have the state variables in mind, just so I know what information is being tracked at each step. So yeah, I'm gonna just push through and look at sending out the data cycle, getting it all working. Which bit do I want to work on first? Out of the data cycle, 1, 2, 3, 4, 5A or 5B. I think 1 is. How does 1 work? 1 is along the lines of like, hey, I have a the client sends a call to the function called start. Then there's some information about what start does that if we loaded Visual Studio Code, we could find that in the notes, but I think that's unnecessary for now. But loaded the IDE, I mean. But it's along the lines of, okay, it sends start, and that has to make its way to the leader, and then the leader has some code about what it does with the data that it just got sent. Well, do you know, I think it is probably for the best to do it all 1 and then 2 and then 3. Just do it in order, because then you have the momentum. This is what happened last, then in the program flow, this is what happens next. And just keep that going from the beginning to the end. Okay, that's why I'm going to start with number 1. Maybe I shouldn't have thought about it too hard. Start at 1 because it is 1. It is the first number. Alright, so let's do that. The first thing that I'm going to do, actually, in that case, is to read the comments that MIT put down on the place where I'm supposed to start implementing that. So let's have a look at that. I'll load up Visual Studio Code. In exactly the right place, because I think I left it there last time. Check it out. Start, kill, make. Okay, start. The bit low on oxygen today, I think. The service using Raft, e.g. the key value service. So that's why I'm using the word service, right? I've already spoken about that. This is it, service. The service using Raft wants to start agreements. The service using Raft wants to start agreement on the next command to be appended to Raft's log, which is Raft's log is kind of like the overall log, I guess. I'm not entirely sure. I'll put the fan back on because the laptop's gone up in temperature a bit, I think. Yep, okay, that'll come down by about 10 degrees. If this server isn't the leader, it returns false. Otherwise, start the agreement and return immediately. There is no guarantee that this command will ever be committed to the Raft log, since the leader may fail or lose an election. Even if the Raft instance has been killed, this function should return gracefully. Yep, well that's gonna be tested because we're gonna have like persistence and stuff in part C, so it's gonna go like it's gonna be a mad thing. Mad thing. First return value is the index that the command will appear at if it's ever committed. Okay, so we have a target index for every command. That's a subtlety. There is a target index for every command. The second return value is the current term. The third is leader. Why not just literally in the function signature we can name the return variables, and that makes it clearer to just read the damn code, right? Then we don't need yeah. Yeah, but that little modification I made there is literally just is leader. Like the function signature up here gives a clear idea of what is sent in and what is sent out, and having is leader on the out means that we have a very clear idea of what we're supposed to be returning before we even look at the body of the function. I think it's a good practice to do that. I think. What's going on here? Cannot use index 1 as type int. That is some chaos. Oh, it's in config.go. Sorry, my eyes. Have I messed something up? Because I have 11 problems all of a sudden. I didn't have any problems before I did this. What? Did you see the problems? They seem to have like nothing to do with. There will probably be problems in the future, but it's basically just the warnings have blocked me from writing a function signature that's clear and understandable. It's just some nonsense, to be honest. Yeah, never mind. So I'm just gonna, yeah. Well, I said why I wanted to do it, and then just some sort of things beyond my control blocked me from putting it in the function signature. But never mind. Let's not get hung up on that. Let's just send it all back to Notepad, and nothing's warning me if I type something wrong in Notepad, so that's good. So yeah, the way I've written this is, I think, maybe not strictly true. I think the client contacts the service directly, and then the service handles Raft. But it doesn't really matter. All I need is an input and an output. I'm calling them client and service, but really, it could just be anything that is handling inputs and outputs. So that's fine. Input. What should I call it? Do I want to call it clients if it's not the clients? In. So I don't want input as in input data. I want in as in the thing that calls Raft, the thing that calls the function to begin the data phase for that piece of data. Let's call it inputter. Calls start, and start literally just takes command, a single command, as its input. Okay, start immediately returns what? I mean, it says here it returns false in certain cases, but that must violate all kinds of type safety. Because if it's true, it returns like a bunch of other shit. I can't just if I type return false here, it's gonna fuck up. Yeah, see, it puts in like automatic variables and all sorts of nonsense. So it's not possible to, the way that this has been written, it's not possible to actually do that. Return index term and is leader. That's what's getting returned rather than anything that could possibly be false. Maybe this is just something that automatically happens before start is called. So maybe the something else within Raft called start. I'm not entirely sure how, this interface section, I'm not sure how it works. I'm much more sound with the internals of Raft because those are heavily blueprinted and this is a bit what? It's not a massive thing. 1:07 is my time so far. Uptime. Just gonna budge the camera down slightly. Yeah, happy with that. If you get too narcissistic, I'm like, my hair. Nah, should be okay. Yep. So yeah, the thought that passed through my mind, I'm a lot more clear on the flow of the program within its internals, but the phases the bits where it's communicating with the outside world, like this, the beginning, it's a lot more confusing. Like, I don't know what returns false. What is it talking about here? Is it talking about start because start doesn't have a signature where it can return false, unless it's the. Oh wait, is leader. His leader should be returning false anyway. In that case it's fine. When it says returns false, yeah, I mean it should be just returning some nonsense and then false. Okay, understood. Why is his leader being set to true? That doesn't make sense. Oh well, we'll fix it later. It should be his leader, not automatically true. Start immediately returns. And what it returns is index term and is leader. My term is, we know what that is. It's just an introspection into the current state of that particular Raft peer, what it thinks the term is currently. And index is is the index that the command will appear at if it's committed. Where the command will appear if committed. If ever committed, yeah, eventually. So that's pretty simple. But then it has to actually do stuff as well. So yeah, the function returns immediately, however you cut it, I think. Does it actually say that? So it says, return immediately. Yeah, it says return immediately. Returns false, that is immediate, and otherwise start the agreements and return immediately. So it returns immediately either way. And that therefore it returns gracefully because it returns immediately. That's completely implied. There's no other way. Start the agreement. If is leader equals true, push push data along. I'm just going to put it start consensus. That's just, yeah, nothing technical there. It's just vaguely what happens. Do you know how we're going to start the consensus though? Well, that depends mostly on the next step. It says leader writes and sends it to followers. We don't have any more hints in the comments of the code, I don't think, so I'm just going to minimize that and get on with it. According to the blueprints, that's what's going to tell us how to handle steps 2, 3, 4, 5a as well. 1 and 5b are more kind of interface stuff, doesn't come under the blueprint so much. As you've seen with 1, it was mostly in the comments and elsewhere, I don't know. Okay, so 2. Leader writes and sends it to followers. Well, what we know is that the leader has the data. That's the result of start is that the leader has the data. So it can do what it wants to it. So we're going to probably make a new function where we just... it's a new leader type function where the leader just does the stuff to the data. Does the things. Okay, so leader writes, leader appends data to log, sends so yeah, append the data to log, followed by send rounds of append entries with the data. So that all comes under the send append entries thing. Append entries receiver Well, the thing is, we already have a system of heartbeats that is continually going off. And what we really want to do is put the data into the heartbeats, rather than sending more extra append entries, RPCs. We want to use the ones we're already using for the heartbeat, but we want those to pick up on new data. So basically, yeah, change this to send sned latest data with next heartbeat. How do we communicate what the latest data is? I would say, okay, so we're talking implementation. I would say there should be a Go channel that the leader sends stuff to. A Go channel where the leader can basically store information to send on to the next heartbeat, and then the heartbeat reads from the channel and bundles up everything that is new in the channel. It drains the channel. Every heartbeat, the channel is drained, and all the data is then sent. Something along those lines. Because we're saying push data along. I think okay, let's add that kind of little piece of little implementation detail, which may change as the sketch progresses. But for the time being, send data to channel type command of type command Send data to channel. Okay, what are we going to call the channel? It's basically a heartbeats buffer channel. You know, it's the stuff that needs to be sent on the next heartbeat. Let's just call it for now data channel. We'll find out if there's a later reason to name it something else if this causes ambiguities or whatever. Drain data chan and forward bundle into next heartbeat. That's my idea for how that should work. Okay. Leader writes and sends to followers. That's the entirety of phase 2. Append data to log, and then the sender drains the data channel and bundles it into the next heartbeat, basically. There's going to be more stuff that comes out of getting all the state variables to work. This is definitely. I'm pretty sure this isn't everything that covers step 2. But let's just go through and do a kind of simplest possible sketch, and then I'm going to add details in from the blueprint. Very nice. Very nice. It's very nice. Followers write and acknowledge receipts. Do I want to? Yeah. Okay, append entries receiver does the following. Picks up the data. I'm going to use the word merge because I think there's going to be, at this stage, there's going to be a bit of acrobatics done by the followers to make sure that they actually have the latest data and that kind of stuff. And that's all we're gonna find out about all that when we read through the blueprint. Merge data with log. Reply true. Timeout auto replies false, but that's something that the will come under the sender implementation rather than the receiver, so I'll move that in a sec. Merge data with log and reply success equals true or something along those lines. For leader. Sorry, I just hesitated for a sec because my fan just decreased in pitch. I wonder if it's breaking down. No, it seems to be fine. That's weird. Just going down, but it stopped. It's fine. Just when something just starts going. Press F for broken fan. Well, don't yet because the fan's working. Yay. Timeout also replies false. Well, the leader then has to, it needs to commit when the majority acknowledge. I'm getting hungry, but I think I have a bit of momentum going, so I'm gonna persevere, the whole 2-hour stream and try to get a sketch down, even if it's not completely complete. I think now is a reasonable time to push ahead with the sketch. Fucking hunger, food, plus blocks. Okay. How do we know that the majority has acknowledged? It comes down to reading the replies. But I think pushing forward with the sketch here, pushing forward with this is going to leave too many suppositions and unanswered questions. So it's time to start looking at the details. The meaty blueprint, which actually does explain pretty much how all of this works better. We have the append entries RPC implementation here. We also have this information about leaders, and everything else that is here is more or less, other than this line, this stuff is more or less only about elections. Yeah, all this stuff I've already implemented, except this line, and most of this. And the first line of these, I have the append entries kicking immediately after election. If command received from client, append entry to local log, respond after entry applied to state machine. Oh, okay. So I'm gonna, okay. I'm gonna write that down here. 5B, reply, where, here, okay. I think the client/service is actually the same thing. I'm increasingly thinking that from the way that they've written this out. It's just that the client is like, I don't know. I think they're the same thing. Reply to client. It says client, so I'm just going to put that down. So I'm just, every time I do a dodgy alt tab, I have to sort of check that my camera hasn't frozen. Where was it? Respond after entry applied to the state machine. Yeah, let's just put that here. Then there is some more stuff here. It's just it's in all these different places, the information that I need. There's a bit of stuff here that's going to need to be implemented, added to the RPC request vote, but that's not. That's to be done later, and it's kind of separate from everything else that I'm doing. So I'm just going to put it down here. Updates, request, vote with data stuff. Okay, just a mental note. This can be done independently of the rest of it, but I think we do need to do it in order for the voting to work correctly, the elections to work correctly when testing for part 2, which actually has data stuff happening in the tests. So what do I look at next? Dear Lord, all of it. I'll look at append entries. I think that's for the best. So append entries has some additional arguments that I haven't implemented yet. Prev log index, prev log term. Index of log entry immediately preceding the new ones, and the term of the previous log index. Senders previous entry index plus term of both. So that's just reading from the log. Of course, we then also have entries, payload. So let me just, again, fitting it all onto one page. Sender's entry before payload. The entry before payload, that's the one we care about. Then we have the payload, which is a list of the next log entries. Empty for heartbeat, of course, may send more than one for efficiency. Yeah, just bundling log entries together. Leader commit is the leader's commit index. Sender's commit index. Results, yep, term and success. Term is fine. Success is, as in done before, success is true if follower contained entry matching prev log index and prev log term. Follower contained entry matching whatever matching means. Follower contained entry receiver, that should say. Receiver contained entry matching prev log entry, which is the prev log index and prev log term, which is, yeah, the two things we match. Oh, okay, so we need to match both. Receiver had, yep. Follower containing, it's just, yeah, weird uses of English as well. So it's equals if the receiver had an entry matching prevlog index and prevlog term. Which is to say that that gets updated on the response, right? I mean... Oh, no, sorry. Huh. Wait a second. This is interesting. This is an interesting detail. You see how success is defined as the receiver having an entry matching the previous log index and term. That means that the send here is relevant. So prevlog index and prevlog term did exist. And that's the entry before the payload. That means that the receiver was up to date. And that means the receiver was in a position to receive the next information correctly, in principle. We send over the next information. But the success is given not based on the next information, but the previous information. So we assume, successful send of append entries is not like, oh, the receiver wrote down what I just sent. It's was the receiver synced up on the stuff immediately before what I just sent, from the perspective of the sender. That's what a success should be. Okay. Duly noted. Let's push through. Then there is some stuff about how the receiver works. Let's just put it all in here. Reply false if term is less than current term. So this should be automatic from term sync. So term is the sender's term, the other term, and current term is my term. If my term is ahead, yeah, current term is my term. If my term is ahead of the other term, strictly ahead, term sync outcome is that the sender is out of date, so yeah, outcome +1, don't forget, is that I wrote that down here, where I defined my outcomes, I think. Or maybe I shouldn't. Maybe I should not use that notation. I should just say if let's just use the standard order relations greater than, less than. But when speaking about servers, one server greater than or less than, I'm going to implicitly define that as the domination, the domination order, which I defined as how do the terms sync, basically. That's a bit easier than using +1 and -1. So basically, what this is saying is reply false if the other is less than I am, current term. But this is the receiver, so if sender less than receiver, which is in general a decent position for a fail. That is the situation in which RPCs should just be ignored. If a sender sends out a message to do something, but it is out of date on terms strictly, then that is a fail. The receiver just does not care. Return false if it fails term sync. That's completely fine. I think that might already be implemented, but not going to look at that yet. Reply false if... What's the other situation? The other reply false situation. Whoops. Went too far. Reply false if log does not contain an entry at prevlog index whose term matches prevlog term. Okay. That's totally fine. I'm trying to get the fan to turn itself off because it started tractoring again, but do you know what, I'll just get that fixed later when I repair this laptop. Fan breaking in laptop. Story of everyone's life. If an existing entry conflicts with a new one, same index, different terms, delete the existing entry and all that follow it. Okay. If conflict my log vs payload same term different term at same index, delete that entry and delete log from that entry to the end of the log. I'm just going to write that way. And then append any new entries not already in the log. Not sure what that means in practice yet. If leader commit is greater than my commit index, I'm going to actually move that information about so it's a bit easier for me to. Nah, I'll leave it there because I need to implement all those variables in the actual structs first. If leader commit is greater than my commit index, set commit index, that's mine, to the minimum of the leader commit and index of last new entry. The minimum of leader commit, and if it is smaller, index of last new entry. Leader commit and the index of the last new entry. This is it. This is what it. God, yeah, this is what I predicted. How hard it would be to get your head around what is going on here. No, I still can't say I understand this, but I'm just kind of drafting it a few times, and then we'll hopefully understand. I'll go over it again in the next session. So yeah, this is how the merge is done. Reply success equals true. It says reply false if no entry, but of course reply true if entry, matching previous log and term. So success equals exactly that. I've just added a line of redundant information that was already written here. Set success. I'm just going to put that there. And then this is the merging these two. Let's just keep the information organized a bit better. Append new entries not already in log. What that means is payload entries that are not already in the log. And then sync commit index. Okay. Yeah, so I'm still not following that well what commit index is. What did it say it was? It's the what I think is the highest committed entry. So this is I mean, the fact that I'm updating this here is means I am kind of It's not that I am committing, because the leader does that. The leader does commits, but this updates to leader commit, as well as the index of the last new entry. I'm not sure why exactly, but this is, I guess, just a synchronization of commit index. Yeah, that's what I've written down here. But the point being, I'm synchronizing my own commit index according to the leader's one, so I'm just reading off the leader. Slash this, which I'm still can't say I understand. That's fine. Continuing on, we don't have to understand everything immediately. That covers all of this. So the last thing we have to look at is just this stuff here. It's funny that this is listed as all server to communicate with the state machine. Is listed as something that all servers do. That's a bit weird. I would have thought only the leader should do that. So this is all about handling last applied and the last phase. Let me open this in a functional web browser so that I can copy and paste. Rip Internet Explorer. Hello, zoom in, please. How do I highlight using? Oh, this is a diagram. I can't highlight. Man, that's just a disaster. PDFs and figure 2. Like, these kinds of diagrams and PDFs really should just be native, not fucking pictures or whatever. Vector graphics, I don't know. No copy. If commit index is greater than last applied, I'm not I'm not entirely clear on what state machine means, actually. Something final, something like the service, but we'll see how it goes. Continuing on, we have some stuff about leaders. These 3 bullet points. So yeah, if command received from client, that comes from start. Append entry to local log. Respond after entry applied to state machine. That's what I've put here. If last log index is greater than or equal to next index for a follower. What's going on? Send append entries RPC with log entry starting at next index. So what the leader is sending is not just it's not just the data, the new data. It's the leader is sending all of the data that the follower needs to keep up to date. So if it stopped following a while ago and is now following again, it's not just going to need what was sent by the start thing, but it needs absolutely everything. So what is getting put onto the heartbeat is not. There's a slight distinction between. Basically, there's a slight distinction between new data that has been, for which a consensus has been triggered, by the service. I'm still sleeping in my bed. There's a slight distinction between the new data being sent and then that being sent off on the next heartbeat, and other just things constantly being synced. The leader always sending stuff, all the data that every follower needs that it doesn't have yet, even if that's not strictly the latest data that was sent to the leader by the client or externally. So there's that distinction. One is kind of a sequence of operations, like okay, a client sends new data that gets forwarded by leader, and the other one is more the leader is constantly keeping things up to date as a cycle that persists with every heartbeat, sending all of the relevant information. So yeah, the latter is more how it's going to end up being implemented, I think. So I'm not sure about my channel idea, data channel, but we'll see how it goes later. That's not highly, yeah. Again, things to be dealt with later when we're done summarizing, I guess. Um, um, yeah, so it kind of describes how it's supposed to work here. Um, Last log index is of course just length of the log in general. Len log is going to be last log index. We'll be seeing lots of that to come. Is greater than or equal to next index for a follower? Send append entries RPC with the log entry starting from next index. If successful, update the two. If it fails because of inconsistency, decrement next index and retry. Yeah, so it replies with false here because of the inconsistency. That's what that is. And also, it replies false in case of term sync. Um, but it says here only if it fails because of log inconsistency should we do that. And so I'm not sure failing because of term sync is a reasonable thing to implement. That's a bit booky. Okay, so let me try to write this down somewhere. Fucking hell. And just try to disentangle what is what. Leader keeping followers up to date on data. Per peer. Um, oh yeah, but I mean the leader keeps track of what next index and all that stuff is. For a follower, send data. Or it says here send the manual append entries RPC. So let's just do that. So I'm going to have to decide later whether I want the heartbeats to dictate when append entries goes out, or if I want to allow manual append entries that jump out of the heartbeat, and should maybe reset the heartbeat timeout, if you see what I mean. Possibly. Some questions to ask there. Send append entries RPC with login. What should be in there? It should be that bit of the log. If success or successful, it's not clear whether they mean what successful means. Does that mean success equals true? It's just not clear. So you can see next index and match index are being maintained here. Whoops. Yeah, best way to write that is like this. Due to what? Log conflicts. Okay. If there exists an n such that, okay, yeah, this is the kind of matching phase. Log writes, something like that. Yeah. To so the conditions for n here. I'm going to write this like this. Set the commit index to the maximum n that is greater than commit index, if existent, such that, and then n has to satisfy a couple of other things, which are match index greater than or equal to n, majority, and log n term equals current term. So many of these, like, I mean, it's such a complicated system. That's it. Okay, I've gone through all that stuff. Whew, chaos. Wow, so much stuff is happening here. Already you can see that, my 2B sketch stuff has actually gotten longer than my code so far summary. Yeah, which, I don't know, that probably says something. Who knows? It's just, yeah, so much stuff. I have implicitly structured this as a kind of cascade of operations. But some of the data stuff is going to have to be sort of always on, looping independently of whether new data has been triggered by the client. So I think disentangling the two, the cascade with the ongoing loops, which are just two fundamental design paradigms for concurrent processes. Disentangling the two is going to make stuff a lot clearer, I think. So that's what I'm going to be pushing for later. Sorry for scrolling rapidly. This stuff, I haven't reread it yet, as in the definition of which log is more up to date, because it didn't really fit with the rest of the blueprints. So trying to, what's the word, bring those two together, trying to, like, if you're merging two ideas together into one idea in your head, it's like, and getting them to agree with each other. There's a word for that, I've forgotten what it is. It's like trying to, I don't know, get them to agree. So there's going to be a bit of that as well, and re-summary, and just try again, I guess, try to make sense of everything. I've tried my best, I guess. Things are kind of, it's clear where everything is. Step 4. I'm going to bundle this here, even though it's not necessary. That's not to say that this is necessarily only going to happen in this cascade of operations, but it's related to this. So I'm just putting related stuff together. And this, I feel like it's a background process that really doesn't fit with the rest of it. So yeah, it's a bit. This is something the follower does, but it's a bit. It's a bit sketchy and complicated. I can kind of understand, the fact that this is happening here, I'm thinking is like, it's actually a difference. The syncing of commit index, it kind of corresponds to step 5a here, followers commit based on the leader, but it's being done at step 3, which means that sync basically is going to pick up probably the previous piece of data rather than the current piece of data. So, a previous data cycle will have gone through, and then the followers will do the commit, which is kind of step 5, but they'll do it as step 3 of the next phase. Because it has to happen, well, the implementation is saying it happens every time there's an RPC, an append entries RPC. And so even if it's just an empty heartbeat, the commit indices will be synced as a result. And so, I feel like, getting a hold of what all of these things mean, what the motivation between each of these steps will allow us to split them up better and decide what goes where, and code them one at a time, still keeping the bigger picture in mind. So, yeah, that's what I think. Honestly, this has slipped again because my butt is hurting again. I'll have to, well, I'm about to finish, I think. Yeah, I'm about to finish anyway for today. Ooh, do not minimize the damn camera. Just don't do it. Don't do it. Also, do not end stream before I'm done. Well, just approaching 2 hours now, in about 10 seconds, I think. So yeah, I guess those are going to be the themes of what I'm doing. Getting the motivation for each individual step. So I'm just talking about what I'm going to do in the next session. Get the motivation for each individual step, so I know where everything should be implemented, where things should be. Do that. Trying to draw a distinction between stuff that is always happening, being synced up by RPCs, and stuff that is kind of cascading as a result of new data. And yeah, reconciling. Oh, reconcile is the word that I was looking for earlier. Well, reconciling this, or which I found in one of the hints, with the rest of it, because it doesn't seem to fit at the moment. Those three things, I think, give me something to do in the next sesh, so I'll go ahead and do them. Thanks for thanks for chilling. Whoever's been around, even if you've just been around for a bit, sending me messages, I've enjoyed it. Always nice to be in contact with people. And I'm just gonna pick it up, continue the sketch. Just basically reprocessing all of this information and hoping to get a better idea of what is what before we start the implementation, the do phase. So yeah, fair enough. It just has to be continued. So I'm literally just going to push forward. And today I am going to get up to date on VODs and GitHub and all that. Well, GitHub is no need. I didn't even touch anything in Visual Studio Code. Oh yeah, I edited too. The text document is part of the Git repository, isn't it? I forgot about that. And what here? I just deleted one line. Just what? Just discard changes, please. What the hell is that? And that's session 10. Yep, and that's it pretty much for today. Git push out. There's only one Git repository. Sorry, what else was I talking about? So yeah, I've been sketching today. I'll continue to sketch in the next session by just going over this and doing those things that I mentioned that I would be thinking about next time. And yeah, I'll get up to date. The Git repository's been updated just now. I just did that. I'll get up to date on the VODs, the collection, and I'll pick it up in the next session. Next session, as a result of what I was talking about in the first 10 minutes or so about the sleepiness and that kind of stuff, and I've just gone hungry now as well because I've been so disorganized. I'm gonna give myself a break until tomorrow, 9 p.m. Tomorrow at 9 p.m. is when I'm gonna just continue, and hopefully that motivates a better sleeping schedule and whatever. I don't want to be this exhausted in the morning because I do prefer streaming in the morning because of daylight. But tomorrow 9 p.m. seems like a shout. It's going to be nice and dark. There will be moths. They'll probably get chopped by the fan, but fuck it. 9 p.m. is a lot more convenient for me. That did happen 2 sessions ago, I think. A moth flew into the fan and got chopped, and I just got shook. But that's totally it. That's everything. So I'll see you guys on the other side, pretty much. On the next sesh, which I have correctly identified is going to be Monday at 9 p.m. I'm not changing my mind. I swear down. I have enough of a break now that it's not gonna cause any kind of problem. So thanks for sticking around. If anyone did stick around, if 0 viewers, I don't care. Streaming is all about just jumping in every now and again. But yeah, thanks for watching bits of it, because that's all I ever wanted. That's not even what I wanted. That's beyond what I wanted. I just wanted to get it out there on stream and practice speaking, what I'm thinking, practice being comfortable on camera in public, on the internet, that kind of stuff. So, all good. Cheerio. See you Monday, 9 p.m.